crop, producing huge quantity of biomass. Its nutrient requirements are thereby high. A 12-month crop, on an average, produces 45 tons of total dry matter per acre. Higher cane and sugar yields cannot be produced and sustained without adequate amounts of fertilizer nutrients. At the same time, the cost of chemical fertilizer has increased, and there is a need to economize its use without affecting productivity. Hence, a better choice is integrated nutrient management, which is a blend of bulky organic manures, chemical fertilizers, and bio-intensive farming. In the integrated nutrient management approach, chemical, organic, and biological fertilizers or manures are used in suitable combinations. These elements complement each other and often produce a synergistic effect that optimizes input use, maximizes production, and sustains the same without impairing the crop quality or soil health or causing any environmental hazards. Since sugarcane is a long-duration crop, it is highly essential to apply adequate amounts of organic manure. Farmyard manure or compost or well-decomposed press mud may be applied at 10 tons per hectare at the time of final land preparation. Green manure crops like daincha or sun hemp should be sown on one side of the ridge on the third or fourth day after planting sugarcane and raised as an intercrop with sugarcane. The intercrop should be harvested and incorporated in situ around 45 days after planting. Fertilizer is the most important component of the integrated nutrient supply system of sugarcane production, being responsible for nearly 50% increase in yield. The most important nutrients required for maximizing productivity are nitrogen, phosphorus, and potassium. Nitrogen is the key nutrient element influencing sugarcane yield and quality. It is required for vegetative growth and root growth. Since the vegetative growth is directly related to yield in sugarcane, the role of nitrogen is paramount in building yield. Deficiency of nitrogen causes paleness of foliage, early leaf senescence, and thinner and shorter stalks. The requirement of phosphorus is relatively lower than that of nitrogen and potassium. However, phosphorus is essential for the formation of proteins and thus for yield buildup. It plays an important role in cell division, stimulates root growth, and is vital for plant metabolism and photosynthesis. It is also required for adequate tillering. It interacts with nitrogen and thus influences ripening. Phosphorus becomes concentrated in plant parts where physiological activity is high. Presence of adequate quantities of phosphorus in cane juice is necessary for proper clarification while processing. Deficiency of phosphorus leads to reduced tillering and delay in canopy closure. Sugarcane is known as a potassium devourer due to very heavy uptake by the crop. It is required for several plant activities such as carbon assimilation, photosynthesis, and translocation of carbohydrates. It is involved in various enzymatic activities of the plant, synthesis of sugar, and its translocation to the storage tissue. Potassium gives resistance to sugarcane against pest and disease attack and lodging. It also helps sugarcane under moisture stress by maintaining cell turgidity. Sugarcane requires large amounts of fertilizer. An average of 200 kg nitrogen, 60 kg phosphorus, and 225 kg potassium per hectare is used up by the sugarcane crop to produce around 100 tons of cane yield. To derive maximum benefit from the applied nutrients, the fertilizers need to be applied at the optimum growth stage of the crop. Phosphatic fertilizer should be applied in the furrow bottom before planting sugarcane sets and mixed slightly with the soil. This fertilizer should not be broadcast on the field. The nitrogen requirement of sugarcane is the greatest during tillering and the early grand growth phase. Tillering phase commences at around the 30th to 45th day. Therefore, the first application of nitrogen should be at the beginning of the tillering phase. In the tropical belt, the first application is done at 45 days after planting and the second top dressing at 90 days after planting. Late application of nitrogen beyond 120 days in a 12-month crop will have an adverse effect on juice quality. There will be continued vegetative growth, late tiller formation, reduced fall percentage juice, increase in soluble nitrogen in juice, water shoot formation and other such problems affecting sugar recovery. Application of potassium is usually carried out along with the application of nitrogen on the 45th and 90th day because nitrogen is better utilized by the crop in the presence of potassium. The nitrogen and potassium fertilizers should be applied in split doses in bands on either side of the cane row. The fertilizer should be covered soon after application in order to reduce nitrogen loss through volatilization. To cover the fertilizer, a partial earthing up must be done after the first top dressing and full earthing up after the second top dressing. Biofertilizers can be applied as a supplemental source of nutrients. Among the various microorganisms, the nitrogen-fixing and phosphate-solubilizing bacteria are significant as they can meet part of the fertilizer need. The nitrogen-fixing bacteria found effective for the sugarcane crop include Azotobacter, Azospirillum and Acetobacter. Application of Azospirillum was found to increase the sugarcane yield by about 10 tons per hectare with 25% saving in nitrogen fertilizers. Bacillus megaterium, a phosphate-solubilizing bacteria, was found to improve the phosphorus uptake and phosphorus availability. An approximately 12% higher cane yield was recorded in phosphobacteria-applied plots over those in which it was not applied. Substitution of superphosphate with rock phosphate to the extent of 50% is possible when used along with phosphobacteria. Regarding the application of biofertilizer, the recommended dose for sugarcane crop is 5 kg of Azospirillum or Acetobacter and 5 kg of phosphobacteria per acre. The soil application method is generally recommended for sugarcane when Azospirillum is applied. Since Acetobacter is an endophytic bacterium, in addition to soil application, set soaking may also be followed. For set soaking, 1 kg of Acetobacter is mixed with 100 liters of water and the sets are soaked in it for 20 to 30 minutes before planting. For soil application, the biofertilizer has to be applied in 2 doses. Half of the dose, that is 2.5 kg Azospirillum and 2.5 kg phosphobacteria should be applied at 30 days after planting and a second dose after 75 days of planting. For application, the biofertilizer should be mixed thoroughly with 500 kg of powdered farmyard manure or compost or press mud and applied uniformly near the base of the crop. Biofertilizer application should necessarily be followed with slight earthing up to cover the biofertilizer with soil. The crop must be irrigated immediately to ensure optimum moisture conditions for proper bacterial growth. The biofertilizer should not be mixed directly with insecticides, fungicides, herbicides or chemical fertilizers as these chemicals at higher concentrations will kill the bacteria. Detrashing is done in sugarcane during the 5th or 7th month. The detrashed trash can be mulched by placing it in the furrows or can be removed and used for composting. On an average, the cane trash produces amounts of up to 15 to 20 tons per hectare. The nutrients available in 1 ton of trash include 3.5 kg nitrogen, 1.3 kg phosphorus, and 6.5 kg potassium. Intensive sugarcane cultivation and the inadequate supply of organic matter have led to micronutrient deficiency. Iron chlorosis is one of the major micronutrient problems observed, particularly lime-induced chlorosis in calcareous soils. Iron chlorosis leads to intervenal chlorosis and stunted growth. This could be corrected by the repeated spraying of ferrous sulfate at a concentration of 0.5% to 1%. Addition of press mud and farmyard manure reduces chlorosis. Another important micronutrient problem is zinc deficiency, particularly in soils where paddy is grown in rotation. Zinc deficiency can be corrected by spraying 0.5% zinc sulfate. Soil application of ferrous sulfate and zinc sulfate at 100 kg and 40 kg per hectare has proven to be beneficial. The nutrient requirement of sugarcane varies with variety, region, soil type, and field. Hence, it is advisable to follow a field-based approach to determine the application dosage.